Can you tell us what you think about the electron?
that if there are subatomic particles called electrons, and I doubt that there are, that if there are, they are not responsible for the force of electricity, and that electricity is not the function of the motion of electrons through conductors. There's so many good experiments for this. So, I was saying before, a vacuum. So you can look at how the propagation of electric waves through a conductor will change depending on the pressure that the conductor is put under. And there's a whole bunch of awesome experiments with alternating current, not with direct current, that show that if you take just a chamber of gas, carbon dioxide works really well, and you have electrodes at either end, and you increase the pressure in the chamber, at a certain point, if the input frequency is in relationship to the gas itself, which is a whole other field, there'll be a certain sweet spot where the input electric wave frequency and the pressure, the actual pressure of the chamber itself, will allow the flow of electric waves through the gas at a higher efficiency than copper. So copper's efficiency is averaged out between 65 to 75% in terms of its resistance to the motion of electric propagation. And you can propagate very useful electric wave through nothing but gas at 95% efficiency. It's awesome. There's actually a paper of Tesla's. I'm trying to think of the name. I think it might even be called a treatise on the propagation of electricity through gases or something like that. But it's around the turn of the 1900s. And so what you get is this problem where if the propagation of electricity is supposed to be the actual motion of electrons as subatomic particles, and since we've moved away from, we used to say as a culture that they were actually flowing. Do you guys remember from high school, you get these stupid images of a water pipe and a tap and a little pump, and they show little bubbles and the bubbles are the electrons, and they flow in this direction, then they flow in that direction, and it's such shit. So then they were maybe in the late 1980s, early 90s, the idea was that doesn't happen. Now there's no actual great net motion of electrons. They call it electron drift. They say that there's an average drift of an electron, but they're giving the value of a few millimeter over hours. So they suddenly pulled right back from the suggestion that it was the actual motion of the subatomic particles moving through a conductor that was causing magnetism, effectively. And so they keep changing the answers in the textbook to suit. So then the problem they run into is they say, well, now the idea is that, like in one of Newton's little rocking ball experiments, one of the current ideas is that, let's say you've got heaps of atoms lined up, in a very rudimentary two-dimensional flat theory. And if you push one, like a hydraulic system, the idea is that the force will motion through the rest of the balls of the electron, and then the force will appear, just like hydraulics, Or that if you were to kind of make one go up, it would create a wave effect. So that's the model that's often used these days to try to suggest that there is a wave occurring, but it only occurs because there are electrons that are waving. So then you take these experiments and you show that you can propagate electric motion, electric propagation through complete vacuums, where there shouldn't be, in theory, any electrons. There shouldn't be any air, particles to be motioned. So then the question is well, what is the wave propagating through? What is the medium of wave?